Hello everyone. Today we will talk about some special types of matrices. In my first video, I have talked about the types of matrices. Now we will talk some other types of matrices. And these types of matrices are based on square matrix. As we know that square matrices are very important. In square matrices, number of rows are equal to the number of columns. So the first matrix we are going to discuss is symmetric matrix. Let us discuss the symmetric matrix. Symmetric matrix, any square matrix is symmetric matrix if its transpose is equal to the matrix. Any square matrix A is symmetric if A dash equals to A, or we can say that, or transpose of A equals to the matrix. Let us try to understand by the help of example. Example, let A equals to 1, 2, 2, 1. Here you can see its A dash means transpose of this matrix, in which what we do, we change the rows into columns, or in a different way, column into rows. So first row I am going to change first row into first column, 1, 2, and the second row into second column, 2, 1. As you see that both this one is equal to this, so here it is A. So this matrix is a symmetric matrix. Let's discuss another example. Any symmetric matrix of order 3 will of this type. Of order 3, any matrix of this type will be a symmetric matrix. Why? Its transpose will be AHG, first row changing to the first column, now second row, H, B, F, then G, F, C, which is similar as A. Okay, we can have an example of this type. Here you see, if I see it, it is the mirror image. The A21 is the mirror image of A12. A31 is the mirror image of A13. Similarly, so if I put a mirror at main diagonal, then we can see mirror image, this mirror image of this, both are same, and this one. So any example of matrix of such type, if I put here 1, 2, 3 at a main diagonal, here 2, minus 1, 0, so here 2, minus 1, 0 will be symmetric. Definitely it will be symmetric. How? Let us find out. A dash is what? Changing this row, 1, 2, minus 1, 2, 2, 0, and minus 1, 0, 3. So you see, this is the same matrix A. So A is a symmetric matrix. Let us go and discuss another type of matrix, skew symmetric matrix. Okay, let's discuss skew symmetric matrix. Any square matrix A is skew symmetric matrix if A dash equals to minus A. That means if transpose of A equals to negative of the given matrix. For example, in the example of skew symmetric matrix, all the elements at main diagonal will be 0, because here the condition is Aij equals to minus Abi. Okay, if A is a matrix of this M cross M square matrix, and if you send this side, it becomes 2 not 2 Aij plus Aji equals to 0. For I equals to j means the elements at the main diagonal, I equals to j. So Ai plus Ai equals to 0, 2 I 0. So since 2 cannot be equals to 0, so I will be 0. It means all the elements at the main diagonal will be 0. So example, first let us have a order 2. Okay, so main diagonal will be 0. Here if I put minus 1, then it will be 1. Let us see what is the A dash, means transpose of this. Transpose of this is 0, minus 1, 1, 0. Now let us multiply by minus 1 to inside and minus 1 to outside, so it becomes 0, minus 1, 1, 0. So this is what? Minus A. Since A dash equals to minus A. So this matrix is a skew symmetric matrix. Let us have an example of order 3. For order 3, there will be a standard example. I am going to fit it. Since all the elements at main diagonal will be 0, 0, 0, and here H, G, F, minus H, minus G, and minus F. You can see the matrix of this type will be always skew symmetric. How? A dash is what? 0, H, G, minus H, 0, F, minus G, minus F, 0. Now multiplying by minus 1 to inside and outside also. So 0, H, G, minus H, 0 plus F, and here minus G, minus F, and 0, which is what? Minus A. Here again A dash equals to minus A. So you can take any suitable values of the H, G, and F, and then you will have a skew symmetric. For example, if I take A equals to 0, 1, 2, then minus 1, 0, 3, then here minus G means minus 2, minus F means minus 3, and 0. This is a skew symmetric matrix. Let us go to discuss another type of matrix. Let us discuss another very important type of matrix, that is orthogonal matrix. Any square matrix A is said to be orthogonal if AA dash equals to I. Means product of A and the transpose of its matrix is I. In that case, this A is called orthogonal. Here some more points we must note that here if such conditions arise, so A dash equals to A inverse. Okay, let us discuss some example. 1 minus 2 2 minus 2 1 2 and this one, and then what will be a dash 1 by 3 1 minus 2 2 minus 2 1 2 minus 2 minus 2 minus 1. Then let us find out a dash 1 by 3 1 minus 2 2 minus 2 1 2 minus 2 minus 2 minus 1 into 1 by 3. This is 1 minus 2 minus 2 minus 2 1 minus 2 2 2 minus 1. When will you calculate this? It will come 1 by 9 9 0 0 0 9 0 0 0 9, and it will give you 1 0 0 0 1 0 0 0 1, which is I. Since a dash equals to I is here identity matrix of order 3. Yes. One more point I want to add. If A and B are orthogonal matrix, then AB is also orthogonal matrix. Okay, and since A dash equals to identity, so A is a orthogonal matrix. Let us discuss another type of matrix, idempotent matrix. Any square matrix A is idempotent if A square equals to A. If this condition happens, then that matrix is called idempotent matrix. For example, let us discuss the idempotent matrix with the help of example. I have taken this example: 2 minus 2 minus 4 minus 1 3 4 minus 1 minus 2 minus 3, which is of order 3 cross 3. A square means A dot A means 2 minus 2 minus 4 minus 1 3 4 minus 1 minus 2 minus 3 multiplied by the same 2 minus 2 minus 4 minus 1 3 4 minus 1 minus 2 minus 3. So we will get, if you multiply it, you will get 2 minus 2 minus 4 minus 1 3 4 minus 1 minus 2 minus 3, which is A. Since A square equals to A, so A is a idempotent matrix. Let us go and discuss another type of matrix. Now let us discuss another type of matrix, that is involutory matrix. Any square matrix A is involutory matrix if A square equals to I. Here I is a identity matrix of the order of the A. For example, let us discuss this matrix with the help of example. I have taken this example of order 3 cross 3. So A is this. So now let us find out A square. A square is what? A into A. Minus 5 minus 8 0 3 5 0 1 2 minus 1. If I multiplied it by itself, 5 minus 8 0 3 5 0 1 2 minus 1. So we will get 1 0 0 0 1 0 0 0 1. So I have got A square equals to I. So here matrix A is called involutory matrix. As I have already told you, the matrices are of a very important use. The matrices are also used in a coding, for a coding of messages, and for another purposes in statistics for the coding. So this is a special type of matrix that is called Hadamard matrices, whose elements are only 1 or -1, and its order is of the type 4T. So let us discuss this matrix. Any matrix of order 4T, T is positive integer, except of order 2, whose elements are either 1 or -1, is called Hadamard matrix. These type of matrices are of very importance in a coding. Let us have an example. 1, 1, -1, -1 or 1 you can have. This is H2, or in case of H4 we can have 1, 1, 1, 1, 1, -1, -1, 1, 1, -1, -1, -1, -1, 1. This is one type of Hadamard. Okay, thank you.